Assalamualaikum and hi everyone. In this video we want to present to you about the field effect transistor, or its short form is FET. So this is our group members from 1DMC. Starting from the left, Mohammad Syafiq bin Ismail. The second one, Shamim Faris Izdihar bin Mohammad. The third one, Amirul Asmawi bin Ramli. And the last one, Mohammad Haikall Danial bin Mohammad Hadi.
Introduction Field Effect Transistor, or we call it FET. FET is also a three-terminal device. For the FET, an electric field is established by the charge present, which means that will control the conduction part of the output circuit without need for direct contact between the controlling and control quantities. Types of FET. The FET is divided by two types, junction FET and metal oxide semiconductor FET. For the junction FET, they have depletion mode. The depletion mode have two types of channel, the N channel and P channel. The second one is metal oxide semiconductor FET. This type is divided by two modes, depletion mode and enhanced mode. These two modes also have N channel and P channel. Basic circuit and symbol. On the left side, this is the P-type and the N-type symbol of transistor. And at the right, this is example of transistor that we use in the lab.
After that, we are going to talk about the operation of GFET. There are three operations we need to know. For the first operation is when VGS equal 0. VGS is the voltage from gate to source and is the controlling voltage of the GFET. The drain source voltage, or VDS, of the GFET transistor is the voltage that falls across the drain source terminal of the transistor. In pinch-off region, the gate voltage, VGS, controls the channel current and VDS has a little or no effect. The result is that the FET acts more like a voltage control resistor which has zero resistance when VGS equal to 0 and a maximum on resistor when the gate voltage is very negative. Under normal operating condition, the JFET gate is always negatively biased relative to the source. We also should know for this operation no gate voltage VGS and VDS is increased from 0. No VDS and gate control is decreased negatively from 0. VDS and VGS are varying. The next operation when VGS is less from 0 voltage. For the N-channel device, the controlling voltage is made more and more negative from each equal 0 voltage level. In other words, the gate terminal will be set a lower and lower potential level as compared to the source when a tiny negative voltage is given to the gate. The size of the attenuation region expands, reducing the total expansive area of the channel and the current flowing through it, resulting in a squeeze effect. The voltage connected to the gate terminal, also known as the reverse bias, regulates the current flowing across the channel between the drain and the source. The gate voltage in N-channel JFET is negative, but is positive in P-channel JFET. When no external voltage is applied, the cross-sectional figure depicts a type N channel with a type P region term. The gate diffused into a type N channel, forming a bias reversal PN intersection and a depletion area around the gate area. Depreciation mode devices are what JFET are called. And the last one is voltage control resistor. A voltage control resistor, VCR, may be defined as a three-terminal variable resistor where the resistance value between two of the terminals is controlled by a voltage potential applied to the third. The voltage at this point is referred to as the pinch-off or cut-off voltage and is symbolized by equal off. The saturation region, which include each of the horizontally fed portion where the FET act as voltage control current source, and the other region that include the slope curve portion is the thyroid or ohmic region where the FET can operate as a voltage control resistor.
Construction defect. N-channel defect is a concept of an N-type silicon bar forming the conduction channel for the charge carriers. The PN junction forming diode are connected internally and a common terminal called gate is taken out from the P region. The other two terminals with source and drain are taken out from the bar. Meanwhile, P-channel defect is a concept of P-type silicon bar forming the conduction channel for the charge carriers. The PN junction forming diode are connected internally and a common terminal called gate is taken out from the N region. The other two terminals with source and drain are taken out from the bar. There is example structure construction of defect. On the left side, we will see the structure and channel defect. Meanwhile, on the right side, we will see the structure P-channel defect. G is a gate, D is drain, and S is source. Let's move on to the construction of MOSFET. The construction of a MOSFET is a bit similar to the FET. An oscillator is deposited on the substrate to which the gate terminal is connected. This oscillator acts as an insulator, which is shears insulates from the substrate, and hence the MOSFET has another name as IGFET. In the construction of MOSFET, the lightly doped substrate is diffused with a heavily doped region. Depending upon the substrate used, they are called as P-type and N-type MOSFET. The voltage at gate controls the operation of the MOSFET. In this case, both positive and negative voltage can be applied on the gate as it is insulated from the channel. With negative gate bias voltage is actually as depletion MOSFET, while with the positive gate bias voltage is actually as an enhancement MOSFET. On the left side, we will see the structure of MOSFET. They have a drain, gate, source, and substrate.
P-channel JFET characteristic. As increases more positively, there are 3 points. The depletion zone increases, ID decrease, which is ID less than IDSS, and lastly, eventually ID equal to 0 ampere. Also note that at higher levels of VDS, the JFET reaches a breakdown situation. ID increases uncontrollably if VDS more than maximum VDS. Transfer characteristic. With a JFET, the input to output transfer characteristic is not as straightforward as it is in a BJT. In a BJT, the symbol of beta indicated the relationship between IB input and IC output. In a JFET, the relationship of input and output is a little more complicated. From this graph, it is easy to determine the value of ID for a given value of VGS. At the x-axis, we put the VDS value. At the y-axis, we put the ID value. Think the transfer curve at the previous graph, there are several steps. The first one is solving for the equation VGS equal to 0 volt. Step 2, we can solving for the equation VGS equal to VP, which is VGS off. And lastly, we can solving for the equation VGS equal to 0 volt to VP. So just for that from us to present about the FET. So thank you and subscribe and like for more interesting video.